Hello everyone, this is a quick video regarding timer and counters in 8051. So let's get going. In 8051, we have two 16-bit timer or counters, and those are controlled by two registers called as TCON and TMOD, where TCON is timer control register, where TMOD is timer mode register. And the count value corresponding to timer 0 and timer 1 are kept in TL0 and TH0, TL1 and TH1 respectively. TL0, this 0 means this register is corresponding to timer 0, and this 1 means this timer TL1 and TH1 are corresponding to timer 1. So let's go and check out the TCON register first. So TCON register is a timer counter control register which is a bit addressable, which is a 8-bit register, and the lower nibble, which is a lower 4 byte bits, are corresponding to interrupts, and these are not related to timer application, whereas the MSB nibble, which is the topmost 4 bits, are corresponding to timers, out of which TF1 and TF0 are called as overflow flag, corresponding to timer 1 and timer 0. So overflow flags is set to 1 by the system when the overflow occurs. Overflow occurs whenever the count value in registers TL and TH, when the count value in registers TL and TH goes from FFFF to 0000. So at this overflow, at this point, these flags are set to 1. If we are using timer 0, the flag corresponding to timer 0 will be set to 1. If we are using timer 1, then the flag corresponding to timer 1 will be set to 1 if when at the point of this overflow. TR1 and TR0 are used to start and stop the corresponding timers. If you set this to 1, this will start the timer 1. If you set this TR0 to 1, this will start the timer 0. By making these bits equal to 0, we can stop the corresponding timers. Now, even though these bits are corresponding to interrupts, let's see in brief. IT1 and IT2 are interrupt control bits, whereas IE1 and IE0 are external interrupt edge flag bits. That means whenever an edge occurs, whenever an edge occurs by the external pin, whenever the edge occurs by the external pin, the flags IE1 and IE0 are set. That means whenever we get the external interrupts on these pins, INT0 and INT1, the corresponding bits are set to high, whereas IT0 and IT1 decides whether to set these flags, IE0 and IE1 by falling edge or by low edge. So this selection is made by using IT0 and IT1 respectively. Let's move to our next slide, which talks about TMOD register. Now we know TMOD register is not a bit addressable register, so we have to set the content of TMOD as a whole, which is in terms of 8-bit. So the lower 2 bytes corresponds to mode of a timer. You can see the 8-bit can be divided into two parts, 4-bit lower bits for timer 0 and upper 4 bits are timer 1, whereas the bits for timer 0 and timer 1 are functionally same. The timer, if we consider the timer 1 as timer 0, the bits M0 and M1 corresponds to the modes in timer. So basically there are four modes listed here. 00 is a mode 0, which is a 13-bit counter. 01 is a mode 1, which is a 16-bit counter and mostly used Mode 2 is 8-bit auto reload timer slash counter, and mode 3 is 8-bit timer counter having TL0 corresponding to timer 0 and TH1 corresponding to T1. This is the difference between all other modes, that is mode 0, 1, 2, 1 and 2 and mode 3. In mode 0, 1 and 2, TL0 and TH0 are corresponding to timer 0, but in mode 3, TL0 corresponds to T0 and TH1 corresponds to TH0 corresponds to timer 0. The next bit, which is C slash T bar, decides whether to use timer counters in counting mode or in timer mode. When we set this to 1, it works as counters. When we set this to 0, it will work as timers. Okay. The next bit is gate bit. Now gate bit decides whether to start or stop the timers using external source. Right. This is used when we learn about interrupts in 8051. This is mostly used when we want to set the timer on in off mode using external sources. Now when we move to timer 1, the or the bit configuration or the functions of these bits are same as that of timer 0, with a one change, that it affects timer 1 and these bits affect timer 0. So with this understanding, let's go and check out how to find out the count values, for particular mode. So first of all, let's make a note that we want to toggle an LED after every 19 milliseconds, which is connected to port P0, which is connected to port 1 pin 0. Here we have connected an LED which we want to toggle after every 19 milliseconds. Okay. So first of all, let's make a statement that we'll be using timer 0 in mode 1. So basically, we want to find out the values of TMOD, TCON, TL0 and TH0. So to find out the values of these registers, let's first go and find out the value of TMOD. Now we know for TMOD, which is an 8-bit register, let's draw it. This corresponds to M0, M1, C/T bar and gate. This is again M0, M1, C/T bar and gate. Now this 4 bits are corresponds to timer 1 and this 4 bits are corresponds to timer 0. We are not using timer 1, so let's make all these bits as 0 0. We are using timer 0 and we are not controlling from external side, so gate will be 0. We are using it as a timer, so make it as a 0, and we are using mode 1 as I have said here, so it will be 0 1. Okay, so ultimately the value of TMOD will be 0 1H. So now we got the value of TMOD as 0 1H. Let's find out the value of TL0 and TH0. Before that, let's talk about TCON. Now, since we are using timer 0, we are concerned with only 2 bits in TCON, which is TF0 and TR0. TR0 starts and stops the timer, whereas TF0 will be set to 1 when overflow occurs. So, we need not to set this TCON value. We have to utilize just this 2 bits. So, let's find out the count values in TL0 and TH0 now. Now, since we want to find out in 19 millisecond delay, which in terms of microsecond becomes 19,000 microseconds. Okay. Now let's consider the oscillator frequency as 12 megahertz. By applying a prescaler factor or division factor of 12, the actual frequency we get for timer and counter circuit is 1 megahertz. So the time for one machine cycle would be 1 upon 1 megahertz, which is nothing but 1 microsecond. So with this consideration, to generate a 19,000 microsecond delay, we will be needing 19,000 microseconds divided by 1 microsecond. We will be needing 19,000 machine cycles. Now to get this 19,000 machine cycles, let's go and think a little bit about the operation which happens internally when we set the count value in TL0 and TH0. When we set TL0 and TH0 and when we start the timer by setting TR0 equal to 1. So by setting TR0 equal to 1, timer and counter starts. So if we make TL0 and TH0 as 0000H, the system starts incrementing the value of TH0 and TL0 one by one at every machine cycle. So it increments TL0 and TH0 by 1 at every machine cycle. It will reach to FFFF in 65,535 microseconds. That means it will reach to FFFF in these many of machine cycles. And we know each machine cycle is of 1 microseconds. It can generate a maximum delay of 65,535 microseconds. But since we want a delay of 19,000 microseconds, we have to initialize TL0 and TH0 at some different location. So what will be this location? The location can be found out by subtracting 19,000 from 65535 minus 19,000. So the value we get by subtracting the actual count which we can use in our calculations. So it is 46,535. So it is 46,535. Now by putting this count into our TH0 and TL0, right? By putting this count into TH0 and TL0 and by starting the timer by setting TR0 equal to 1, the system will increment this count up to FFFF, which is 65,535, and after this, again by incrementing 1, it will roll off from FFFF to 0000, which results into setting of a flag TF0, that gives us an indication that the timer has achieved the desired delay. The timer has achieved the desired delay, and by checking this flag, we can perform our desired operation. So now as we came to know, the delay or the count required to generate the required delay is calculated by subtracting the 19,000 from 65,535, which is 46,535, right? And by setting TR0 equal to 1, will start timer, and this count will go on increasing up to FFFF, and by counting it again one more time, it will result into 0000, and this transition is the overflow which makes TF0 is equal to 1. By checking this flag, we can come to know that the desired delay has obtained. So the program flow should be first to set the values of TMOD, TL0 and TH0 in respective registers. In our case, TMOD is 01H, TL0 is the hex conversion of this plus 1, right? So the actual delay is 46,535 plus 1. This 1 is required to generate the overflow. So one extra count we have to add. So it is 46536. In hex, it is B568, B5C8, B5C8 in hex. So the value of TL0 will be the lower byte, which is C8H, and TH0 will be B5H. So with this knowledge, let's go and start coding. So we'll start coding from 0000H. We'll ljump to starts. So we'll come here at a start location. This line is not needed. Even if you remove this line, does not affect the program. So we'll make this port 1 as output because we want to interface our LED at pin 1.0. Then we'll set the value of TMOD by instruction MOV TMOD comma #01, which indicate immediate data 01, which goes into a TMOD register. Then we'll set the values of TL0 to C8 and TH0 to B5 using this instruction. Once this is done, we'll complement the pin P1.0. That means if pin 1.0 is 1, it will be set to 0, and if it is 0, it will be set to 1. It will just complement, which keeps on toggling the LED connected at this point. After that, what we do is we'll start the timer at this point, and we'll keep on checking for the overflow occurrence. Whenever the count we have placed, which is B5C8 in TH0 and TH1, when it increments and moves to FFFF and then FFFF to 0000, at this point this TF0 will be set to 1, and that's what we are checking at this point. Once this is done, that means the desired delay of 19 milliseconds is achieved, and after this delay what we do is we'll clear PR0, which stops the timer, and we'll clear this flag TF0 so that we can use it in further cycle. After that, what we do is, since we want this toggling to be continued for infinite time, we'll jump again at this point where reinitialize our count and this cycle repeats. So this cycle keeps on repeating and making the toggling of LED after every 19 milliseconds. So this is all for the timer 0 in mode 1. In subsequent lectures, we'll see how to set the timers in different modes and use it for generating pulses as well as the square waves.